Right, so welcome back again to my YouTube channel. So in the last video, you have learned about inception. So how inception network works. You have learned about the like what is the use of inception and all that. So in this video, I'm going to cover a specific topic of deep learning called batch normalization. Just say batch norm. Right, so it is a very popular technique that has been used in computer vision, also in different neural network problems. So first we'll discuss what it is, like what problem does it solve, why do we want to use it, and then what advantages it has. So first, for context, let's start off with an example. So let's say you want to build a normal neural network. Let's say you want to build a neural network. Let's say, for example, the inputs are, I'm not going to define the problem. Let's say the inputs of the neural network are something like net worth, probably salary. Let's say, the inputs are yearly salary. Let's say yearly income, right? And then the next feature is, let's say we have two features, so yearly income and age. Let's say, so this is the problem. Let's let you have this. Both of these are inputs, yearly income and age, to the neural network. So the problem here is this yearly income can range up to from let's say $1,000 or $10,000. This yearly income can range up to $10,000 to, let's say, $1 billion, or probably $1 million, $1 million. So there is a huge gap here, right? So the difference between, like, just look at this scale, right? There is like a huge possible number of features, and the inputs can sometimes can sometimes be very low and very high. And then let's say this, and the next feature, age, right? So this just varies around, let's say, 1 to 100, or probably 18 to 100, working professionals, or 80 to 18 to 60. So here age is a very small range, and yearly income has a very large range, right? So that is why it can lead to neural network instability, and also it can lead to a problem called exploding gradients, in which in which some gradients increase exponentially and other gradients fall off. So we don't want that. We want each of this, both these features, uh, given same importance. So we want both of these features to be given the same importance. So therefore what we'll do is we can just convert this in these outputs, or this values, into the scale of 0 to 1. So what we'll do is we'll subtract these outputs, we'll subtract the mean, right? So we have a lot of this yearly income, so we'll just subtract the mean and divide it by this our standard deviation, right? So we'll have standard deviation as 1 and mean as 0. Hence we will convert the values between the range of 0 to 1, and then, or probably any range, and then we'll convert this age also into a specific smaller range. Hence we could lead to better stability of the model, hence giving better gradients, not and hence we'll solve the problem of exploding gradients, partially solve the problem of exploding gradients. But another problem is, let's say we have a neural network, right? This input progresses to the neural network, and sometimes let's say this neuron's output is very larger compared to this neuron's output. So what happens is, hence it will also lead to instability. Then this neuron's output will be very, very large, hence causing a problem of exploding gradient. So what we'll do is we'll just simply add another, we'll also normalize each neuron's activation. So we'll normalize each neuron's activation, and then hence stabilizing it. And we also have, we'll normalize both of these values. So let's say this is z, so this neuron's output is z, let's say. So what we'll do is we'll normalize z, right? So we'll normalize z. This neuron's activation, we'll just normalize this activation, this z. And then what we'll do is we can just multiply that by gamma and add beta, right? So we'll have these learnable parameters, gamma and beta. So what does gamma do is we'll scale it, and beta will add it. So these are learnable parameters, by the way. And then why do we need this gamma and beta? Means this gamma and beta, like these learnable parameters, can also act as a regularizer. So what is a regularizer? Well, you learned about dropout, right? I have already taught you about dropout and what is the use of dropping out neurons, reducing the complexity to solve the problem of overfitting. So therefore, these batch normalization also acts as a dropout, and sometimes these gamma and beta will convert will be optimized with respect to the loss function. Since this sometimes will cut out the neurons, maybe convert this output activation into zero. So therefore they also act as a regularizer. They'll reduce the output whenever necessary. So that is batch normalization. I just want to make a quick video just to make sure that you're comfortable with it. That's it. That's it for batch normalization. We'll just convert these outputs into a specific range, and we do this. We'll have this learnable parameters. We'll multiply and add, and then we'll also have reduce the mean and have standard deviation. And another reason why we add gamma and why we add these parameters is because they can give a new mean and new standard deviation for this data. Since we'll also do this. So thank you for watching, and see you in the next video.